Okay, so today we're going to look at slope as a rate of change. What you did for your project, right? You're collecting data. There's not a lot for you to look at with the data except for increasing, decreasing, maxes, mins, and what the rates of change are. And so the first page is just looking at how to interpret slope with units, okay, which is what you're going to do. And then the second page is looking at average rates of change, but from a table as opposed to an equation, which is what you have in your project. Okay? This is to help mimic some of the questions you can ask yourself about your data sets and then answer with your data. Okay, so we're going to slope as a rate of change. And rate of change. Okay. In this particular case, X and Y, they have different units. Okay. Sample, miles per hour. Cost per unit, miles per gallon. Here's a good one. Population per time, revenue per time or year. The units on the X and the Y axes are different. They don't always have to be per time. It could be per unit, per gallon. Okay, a manufacturing company determines the cost in dollars of producing X units of a product is. Okay, so I'm going to look at what my X label is. X is number of units, and we'll say C is cost. That way the slope is cost per unit. We're going to start there. The marginal cost, and some of this is just vocab. If you're taking the econ class, some of the vocab is the same. It just looks a little bit different. Okay? This is your slope. So what is it? It's change in Y over change in X. In this particular case, right, I can look at that MX plus B. It's the slope. It's 25. But you have to include units. 25 doesn't mean anything. $25 per unit. A lot of times you make this per 1 unit because you divide it, right? You wouldn't necessarily say 2/3. You would say $0.6 per unit. Okay, your fixed cost is the cost that you can't get rid of, right? It's how much it's going to cost you with 0 units. Buy the machinery, set up the building, turn the electricity on. Whatever that fixed cost is, it has nothing to do with actually producing the units. Okay, so in this particular case, right, remember MX plus B, it's that B value. What could it be? Okay, it could be a down payment. Could be the initial, anyone take physics, initial cost, that's times 0. It's eventually what we do in here looks like what you do in physics, eventually. Okay, times 0. A lot of times if you're talking about a market, this is your capital. It's the money you have to start before you can actually begin. You have to have a certain amount of money to begin the production. Okay, so that was just defining the parts of the equation. Number 2. Read it, see if you can write a linear equation. Okay, defining your variables. Sales per share in terms of year. In terms of, that means that's the input number. So this is like your Y, this is like your X. I'm just using S so it represents sales. Notice I asked you to relabel your input. That's 2012. Write a linear equation. So we have the point. Right, if I want a linear equation, I need 2 points. Now that you have the 2 points written with the correct input, right, 1 and 2, write the equation in a line. Right, use a calculator, guys. I don't need you to do this arithmetic in your head. Okay, so I'm going to do a third point here. And I'm just going to give my X and Y a title, right? X is years and sales per share. Okay, so what are the units on your 2.04? Okay, dollars. What's the other units? Years. Okay, so, right, how are you going to label your axes? So we have, it's sales per share in dollars. That's the sales per share in dollars per year. And you can say over year. So each year it increases by about $2 per share. Okay, what's your equation? Okay, y minus y1. Slope, x minus x1. 2.04 x minus 1 plus 15 points. Right, I just solved for y. Just move that y1 over. Graph it. Sketch a graph. Only label what you need to. It does not have to be a square grid. I don't expect you to count by 1, 2, 3, 4, 5 and then 1, 2, 3, 4, 5. Label the points you need. So put a break in the graph if you need to. 1. There's my first point. 1. 15.75. 7.1. Okay, and we got years, sales per share in dollars, right? I abbreviated. Okay. Two, rise, run. 3, rise, run. What would the third point be? Which you didn't have. Right, I'm just counting slope. What would your third point be? Yes, 0.79, 19? Yeah, 19.7. It's just slope. It's just a linear equation. Just slope. Okay. Estimate the shares per year in 2013. Estimate, that's a prediction. You can estimate any value after you have the equation. Okay, y, and I should have done this, right? Instead of using y, I should have changed it to sales. Use the actual variables in my question. Okay. Sales in 2013. What's t equals 3? Now, we already put it on the graph, but how would you do it in your equation? You would plug it in. Okay. Sales per share in dollars. I'm going to say in 2013. That's the year that I was estimating for. Okay. Do number 3. We're not going to compare to the actual right now, but you could look it up. Okay, this is about including units with your answers. Okay, there you go. Relabel it that way. Let's write up an answer. Okay. Linear equation that gives diluted in terms of t. Okay, so I have my points. 7, 1.43. 8, 1.55. Okay, so my slope is can't add 0.12. Okay, units, and in this case it looks like the graph is already labeled for you, so that makes it easy. Per year, diluted, I'm just going to put EPS per share, okay, dollars per year. 0.12. It's a lot less than this one, which was 2.04. Okay? Equation. Diluted equals 0.12 t minus 7 plus 1.43. Now you can solve for, okay, you can write it out, which would give you the y-intercept. Okay, 0.12 times negative 7 plus 1.43, 0.59. Okay, right? You could see the y-intercept times 0. You can see the slope. What would you get if you predicted 2009? Okay, well that would be 9, following the trend. Plug in 9. 0.12 times 9. Guys, it's not the arithmetic that you have to worry about. It's like actually reading the question, making sure you relabel the variables in the right way, making sure you include the right units, making sure you know 2009 means 9. Sometimes 2010 is 10, not 0. Right? Making sure you interpret the input and rewrite it in the correct way. Okay, so we get 12 times 9. Okay. $1.67 units. Okay. EPS per share in dollars in 2009.
It also says it on the little graph over there.
I know. That's because I gave you the graph in this particular case. Notice that it's the same thing we did on the graph above. Yes. You have a table of data. You can look at slopes between 2 points. You can look at slopes between multiple points. Okay, average rate of change is slope between 2 points. Any 2 points. We just call it an average rate of change. Okay, typically you have a starting point and a stopping point. Doesn't necessarily have to be next to each other. You can pick any 2 points in the data or on a graph. Okay, a good one. 94 miles to Richmond, approximately. Takes 2 hours, hopefully.
I'll do Washington and Philadelphia.
Okay. What's your average rate of change? And sometimes we abbreviate this AROC, average rate of change. Now you start at 0, 0. 0 miles, 0 time. 94 miles, 2 hours. So your 2 points, 0, 0 was miles. Nope. Let's go hours, miles, hours, miles. Okay, there are your 2 points. You start driving, you start at 0, 0. So what's your average rate of change? Change in Y over change in X. Keep in mind you have units. 47. Include your units. Miles per hour. Notice that I figured out what my X and Y were before I found my slope so that I would have units to go with it. Okay. Why might you want to know the average rates of change? Okay, so we have annual sales. If you haven't collected data yet, revenue for any company is an easy one to collect. Table shows annual sales in millions of dollars for the Dollar Tree and the 99-cent only store from 2005 through 2009. Okay, notice that they've relabeled the input right here. Look at how the data is labeled. Really easy to read. When you turn in your data, you have to make sure that I don't have to ask you what it is. If I have to ask you what it is, then you didn't put enough information down. Okay, I should be able to tell how you're labeling it, what the X is, what the Y is. If you need to write me a sentence off to the side, like a legend explaining it, then you write a legend explaining it. But I shouldn't have to guess what your units are and what your data represents. Okay, the average rate of change for each company between 2005 and 2009. Okay, so here's dollar store. There's 1 point. Here's the other point. 99¢, here's your other one. Find your average rate of change. Slope equals 5231 minus 3393 millions of dollars in sales per year. Okay, units. Because it's not the arithmetic you're looking at. It's like how to actually say your answer with the correct units. Okay, so over 4 years, the average rate of change was $459 million in sales per year. Means it increased about $460 million every year. Right? Notice I just rounded it. That's fine. Okay, so I said the words increase each year. Right? Think of how you can ask questions and answer them. Okay, let's do 99¢ store. So slope is $1 million in sales per year. So obviously the Dollar Tree did a lot better than the 99¢ store. Okay, so I'm going to write one sentence off to the side. On average, dollar store sales increased by approximately $460 million each year for 4 years. Okay, so we looked at 2005 to 2009. What if you look for the greatest or least change? Right? Which year had the biggest increase? Which year had the least increase? I'm just going to make myself a little table. 5 to 6, 6 to 7, 7 to 8, 8 to 9. Could you just do this in your calculator? Yes. But I have those 4 year spans to look at for the greatest or the least rate of change. Okay, so I'm not going to write slope down. I'm just going to calculate it and then record it. Now, notice this is only 1 year span, 3969.4. Okay, 575.5. Okay. 6 to 7. Okay. Right, I'm not including units. I'm just looking at the actual change in the numbers right now. 728, okay, 4644.9 minus 4242.6. Okay, 402.89. Okay. 5, 2, 3, 1, 2 minus 6. Okay, greatest and least change. Greatest, least. Which year had the greatest change? Why? Right, that's a question. Okay, see if you can tell by scanning the data up here the greatest and least change for the 99-cent store. About 80, 85, 155. Okay. 7 to 8, I think, is the greatest. Least. Right, I just looked at the difference in the numbers. I'm pretty sure I got it. This one was about 80. This one was about 95. Okay. We have a couple different numbers here. So far, the only way I've told you to make a prediction is to write an equation, plug in a value. Now you're looking at rates of change. Can you use the rates of change information and make a prediction about what's going to happen next? You can make predictions any way you want, okay? Usually you're like, oh, I just type in my X and I press enter. You get a number out. But can you look at it a different way? Maybe your regression equation isn't reasonable. And you're like, gosh, I wish I could just say the point's supposed to be up here because that's what it looks like it's going to do. Okay? Use your rates of change to make a prediction. For example, right? This is flexible, guys. There's no like one way to do this. I see the Dollar Tree that I have rates of change. 1, 2, 3. Okay. So the rates are going up each year. So I think for the next year, approximately rate of change 600. Each year it looks like they're going up. So I think the next rate of change is going to be 600. So in 2010, okay, I got to go back to my data and figure out my rate of change. Okay, so I'm going from 5231.2 plus 6. I think that's how much it's going to go up by. Looking at the rates of change in the table. Each year the rates were going up. So I guessed 600 for the next rate of change. Where'd you leave off? You left off at this data point here, 5231. So I added 600. So in 2010, approximately 58 31.2. I'm only leaving off units because I have limited space here. Okay, that's one choice. Maybe you feel like that's not a good idea. Maybe I just want to take my average rate of change and add that instead. Guys, you can get minimum predictions and maximum predictions. Okay, or average rate of change from 5 to 9 is approximately 460. You don't need to use decimals, you're estimating here. Okay, so in 2010, 5231.6 plus 460, approximately there's your two predictions. Two different ways. One, I just estimated what I thought the next rate of change would be. The other way, I just looked at the average rate and I said, okay, I think this is a good middle ground. Not too high, not too low. Okay, pick one choice, guys, for the 99-cent store. Pick one choice. Look at your rates of change and make one estimate based on the slopes you see in the table. You could all have different estimates. Okay? I picked a rate of change of 50. Right? I looked at my data. Notice that this data is still increasing, guys. It's just not increasing as much each year. The rates of change went up, then it went down, but it's still going up. Okay? So I thought that maybe saying 80 might be too high because it looks like the rates of change are leveling out, right? They're coming back down. So I guessed 50 again. I didn't want to go lower because I'm not sure the rates of change are going to be lower. So I picked 50. And that might be a minimum estimate. Doesn't matter. It's just an estimate. Okay, two ways to do this. Regression equations, look at your rates of change. You can compare the two and then make an estimate based on that. Okay, as a review, write a regression and find a prediction for 2010. Right, you've got your 4 data points, your 5 data points up there. Okay. Use a regression equation and make an estimate. Pick one, right? Don't do both. It's the same steps for both. Pick either Dollar Tree or 99-cent store. Write an equation make the estimate. You can use your calculator, Excel, Desmos,